Okay guys, so after proceeding first to your example, sa ating mga example problems, I need first to introduce to you the consistency of soil kasi kailangan natin ito pala in solving those examples. So the term consistency of soil. So before defining the meaning of this consistency, allow me first to tell it to you that yung consistency of soil is also termed as yung tatawag nating Atterberg's limits. So, ang tawag dito is also your Atterberg's limits. Okay? So, ang Atterberg's limit natin kasi, the word Atterberg's here is a person who developed a method for describing the limit of consistency for fine-grained soils by moisture content. Kaya tinawag siyang Atterberg's limits. So, from here, si Albert Maurits Atterberg, he is a Swedish scientist. Okay? A Swedish scientist, yan, scientist who developed the method of what? Develop the method of describing what? The limit of consistency. Develop a method for describing the limit of consistency of fine-grained soils by moisture content. Okay? So, that's it. Sabi niya, si Albert Maurits Atterberg developed a method for describing the limit of consistency of fine-grained soils for moisture content. The word fine-grained soil here, guys, alam naman natin kung ano yung mga fine-grained soils dito. Tama ba ako? Inulit ko, ang fine-grained soils natin are your silt and clay. That is why the type of test we need to do here is yung Atterberg's limit. So, through your Atterberg's limit or by Atterberg's limit, hindi natin pwedeng i-describe yung limit of consistency for your coarse grain soil. Okay? So, ang i-describe lang natin limit dito of consistency is for your fine grain soils, which is your silt and clay by your moisture content. Okay? So, now, let me define again what would be the meaning of this consistency. Ano ba nga bang ibig sabihin ng consistency, sir? Ang consistency is the term used to describe the degree of firmness of soil. Okay? A term used to describe the degree of firmness of a soil. Okay? Yan. Ang ibig sabihin ng consistency. Kasi dito, through this firmness, ang firmness kasi ito yung tatawag ng whether your soil is soft soil, medium, or firm, or hard. Okay? So, example dito, it's either soft, medium, or hard. Or ibig niya sabihin yung term na firm. Okay? That is what we call your consistency meaning. So, consistency is the term used to describe the degree of firmness. So, the consistency of this fine-grained soil or your cohesive soils, guys, is greatly affected by the water content of a soil. So, there is a gradual increase of the water content that may transform sa dry soil, mag-start tayo sa dry soil, papuntang solid state to semi-solid state to plastic state and after further moisture increase into a liquid state. So, that's why concept ni Atterberg, guys, is these limits are liquid limit, plastic limit, and shrinkage limit. That the limits are based on the concept that a fine-grained soil can exist in any four states depending on its water content. And again, the water content at the corresponding junction points of these states are known as the shrinkage limit. Inulit ko lang. Sinabi ko kanina, plastic limit, and liquid limit respectively. Okay, so I will give you the figure of this one. Through this consistency limits, I have here at my x-axis would be my water content, at my y-axis would be your volume. So, dito tayo ngayon. Water content natin to guys. Water content natin yan. And through this one, siyempre sabi ko nga, there is a gradual increase of the water content. So, from your dry soil, yun yung solid state, di ba? So, from your solid state, siyempre wala pang water content dyan. Zero pa lang, meaning to say, constant pa rin siya. Okay? Until sa time, kapag naglagay na, mayroon na siyang water content, there is a gradual increase of the water content. So, mangyayari dito, pag nag-start na dito yung nagkaroon ng water content, there is a gradual increase. So, ganyan siya. So, if we're going to divide this one into 4 state, yan. Okay. So, this it. This is termed as your solid state. Okay, bakit siya uniform pa rin dito? Kasi solid pa lang siya, wala pang water content dyan. And then from here, meron tayong tinatawag na semi-solid state. Right? And then we have here your plastic state. And then lastly, we have here your liquid state. Okay. Sabi ko kanina, the water content, di ba ito yung water content natin? And then this one is your volume. So, that ko lang. This is your volume at y-axis. Yan. The water content at the corresponding junction points of these states are known as what? So, ito yung corresponding junction natin. Point natin, junction points natin to. Ito mga yan. Ang junction points dito, ang tawag sa kanila, from solid state to semi-solid state, ang junction points niya would be your term as SL. The word SL would be, or the term SL is yung tatawag natin shrinkage limit. Right? And the junction points between semi-solid state to plastic state is called as your plastic limit. And then, term as PL, plastic limit. And then, the junction point between your plastic state to liquid state is termed as your LL, or your what we call your liquid limit. Okay. So that would be the figure of your consistency of soil. So meaning to say, these limits are based on the concept that a fine-grained soil can exist in any 4 states depending on its water content. Those are solid state, semi-solid state, plastic state, and your what we call your liquid state. So let me define what would be the meaning of this shrinkage limit. Ano nga ba itong ibig sabihin ng shrinkage limit natin? Ang shrinkage limit natin, guys, shrinkage limit is the moisture content in percent at which the soil changes from semi-solid to solid state. So it can be considered as the minimum water content at which no decrease in soil volume. Nakuha niya? So ito yung ibig sabihin ng shrinkage limit. So your shrinkage limit is expressed in terms of percent at which the soil changes from solid to semi-solid state to solid state. And then, sabi niya rin dito, ang plastic limit din natin, ito yung moisture content natin in percent at which the soil changes from plastic state to semi-solid state. And then, yung liquid limit naman natin is defined as the moisture content in percent at which soil changes from liquid state to plastic state. So, this term or all your limits because of the effect of your water content. And one thing more we need to know here is yung tinatawag nilang PI. PI, or it is termed as your plasticity index. So, what does it mean by this one? Plasticity index. Ang plasticity index natin, guys, is the range in the moisture content when the soil exhibited its plastic behavior. So, is the range in moisture content when the soil exhibited its plastic behavior. Its plastic behavior. Okay? So, from here, there's a formula here for your plasticity index that your PI would be equal to liquid limit minus plastic limit. So, this is your formula here. And based from the formulas that I give it to you before, meron tayo dito formula tayo sa PI. Yun. Your plasticity index, this one. Plasticity index, liquid limit minus plastic limit, which is termed as the range in the moisture content when the soil exhibited its plastic behavior. Okay? And then, one thing more. Ano ba kailangan natin malaman sa Atterberg's limit na yan? Ano ba yung discrepancy, sir, kapag mataas yung water content at mababa yung water content? Take note of this one, guys. Water content significantly affects properties of your fine-grained soil, or which is your silty and clay soils, unlike for your sand and gravel. Ngayon, pansinin nyo, kapag masyadong mataas, this is the concept or the principle. Kapag masyadong mataas yung water content natin, expect yung strength decreases. Okay? At pag mataas ulit yung water content natin or your water content increases, expect there is a swelling for your soil. Magsiswell siya. Okay? And your fine-grained soils at very high water content possess properties similar to liquids. So, kapag na-reduce naman yung water content mo, the volume of the soil decreases. And the soil become plastic. Okay? So, next, if the water content, yung water content natin, further reduce, the soil become semi-solid. And when the volume does not change. Okay? So, napaka-importante nito. Lagi yung tandaan. Kaya inulit ko, when your water content increases, expect the strength decreases. When your water content increases, expect there is a soil swelling. And when your water content is reduced, the volume the soil decreases and its soil become plastic kapag nagre-reduce na siya. And if the water content is further reduced, simply expect mo the soil becomes semi-solid. And when the volume does not change. Guys, take note that Atterberg's limit are important to describe the consistency of fine-grained soil. The knowledge of the soil consistency is important in defining or classifying a soil type or predicting soil performance when used a construction material. And lagi nyo rin tandaan that fine-grained soil usually exists with its particles surrounded by water. And lastly, the four states that use here, again, just for review, is used to describe the soil consistency is what? Solid state, semi-solid state, and plastic state. Right? So, yun lagi nyo tandaan. So, ngayon, in your laboratory activity later on, wala kasing face-to-face na, tama? In your laboratory, if there's a face-to-face sana, mga, diba? Pero I send you a link, diba? Sa laboratory kasi natin, ito yung mangyayari. Ito kasi yung tinatawag kasi natin Casagrande Cup device. Okay? Ito yung Casagrande Cup device natin, guys. Okay? Yan yung Casagrande Cup device na gagamitin natin for your testing of your liquid limit. Kapag plastic limit naman, yun yung fiberglass. Okay? Meron tayong fiberglass. Yan. Ito yun. I-roll mo yung soil sample mo dyan. And then, kapag shrinkage limit naman ang gagamitin, it would be your evaporating dish. Right? So, yun yung mga importance ng mga ng mga liquid limit, plastic limit, and shrinkage limit. And that's why when we talk about those limits, ang concept dun is all about yung water content of the soil. Okay, next. Punta naman tayo dun sa tinatawag nating soil indices or yung index natin. So, meron tayo dito, tinatawag kong soil index natin. So, yung mga soil index natin, either tatawagin natin siyang plasticity index, liquidity index, and shrinkage index. And then we have later on also your activity of clay or your fine-grained soil. And then we need to define what would be the meaning of this one, and i-correlate natin siya ngayon. Right? Okay. For my first column, I have here my index. Index, yan. First column, index natin, we have here your plasticity. So, meaning to say, plasticity index. So, PI na to. Tama? Plasticity index. And then, we have here the definition. And also yung correlate natin siya, correlation natin. Okay? So, plasticity index, or this is denoted as PI, which is equal to your liquid limit minus PL. Ay na-introduce ko kanina. Okay, that's the definition. So, i-correlate natin siya. Correlation nito is for the sake of yung strength, compressibility, ayan, and yung tinatawag lang compaction or compactibility. Okay? And then next, one thing more, we have here what we call your liquidity index. Liquidity index, LI. So, LI ngayon siya. Ang LI natin would be omega minus PL all over PI. Okay? So, I have here my mnemonics, pero masyado yatang ganyan. Pero mabilis lang naman kasi siyang i-memorize. Kaya dito, masyado kasi siyang green to. Pag i-mnemonics ko, ito meron din siyang mnemonics to para mas maintindihan nyo. Anyway, the correlation of this liquidity index is equal to your, for the sake of your compressibility and stress rate. Ayan. Stress rate. And then we have here your, what we call your shrinkage index. Shrinkage index. So, this one is SI. Denoted as SI, PL minus SL. Siyempre, this one is the term for shrinkage potential. Shrinkage potential. And lastly, we have here your activity of clay. So, one time before, nung time nila Ariston, so Sir Ariston lumabas na tawag dito, quiz B nila to. Okay, for your activity of clay, this one would be equal to your, or denoted at AC is equal to PI all over mu, wherein your mu here is percent of soil finer than 0.002 clay size. Okay, sulat ko lang. This one is where mu is equal to the percent of soil finer than 0.002 mm. So, clay size ito. Clay size. Yes? So, yung value ng PI mo, substitute mo lang, divide mo sa percent soil finer than 0.002. Yun na yung magiging activity of clay natin. Siyempre, sabi ko nga, expect mo sa clay mo, magkakaroon ng swelling. So, correlate natin to sa swell potential. Swell potential. And then, etc. Okay? So, PI would be LL minus PL. Plasticity. Liquidity naman. omega minus PL all over PI. So, ito yung mnemonics ko dito, okay? PI-LI, di ba? Pag pinaghalo mo, pili siya, di ba? So, parang ganito. Si Juan ay mapili, kaya mapala. Okay, that would be the mnemonics. Si Juan ay mapili, kaya omega is yes, mapala. Okay, that would be the mnemonics. And then, shrinkage index, SI minus PL, and activity of clay would be equal to your PI all over mu. And again, these are your soil indices. Ito yung mga index, soil index natin. So, dito nasa formula natin yan. So, kaya dito, liquidity index. Ito siya, number 26. Okay? And then your, saan pa yun? Consistency index, di pa nilagay, mamaya pa. Activity of clay, this one, activity of clay. This one, guys. Yan. Percent of clay size. Then, SI and then CI. Yung CI natin, consistency index LL minus omega divided by LL minus PI. Okay? So, ngayon, for your activity of clay, guys, for your activity of clay, dito sa activity of clay natin, lagi niyong tandaan, activity of clay. Okay? So, ito yung magiging classification natin. Sa activity of clay mo, kapag AC is less than 0.7, inactive clay siya. Inactive clay. And if your AC is less than 1.2 but greater than 0.7, normal clay siya. And then, if your AC is greater than 1.2, active clay siya. So, this would be your classification, active clay, in order to determine yung AC. Okay? So, I will introduce more to you in our next videos, yung description naman of soil based on liquidity index and plasticity index. So, see you again, guys, sa next video. Thank you.